So children, magnetism definitions we will discuss. Electromagnetism definitions. All definitions we will discuss. Okay. What is the first definition in this lesson, children, we have? Yes, anyone? What is the first definition we have in this lesson? Yes, children, what is the first definition we have? Magnetic field.
Magnet field.
Magnetic field. What is magnetic field, children? Magnetic field means around in the space around the magnet. Okay. In exam, if question comes, please draw like this, children. Okay. It is the space around the magnet in which its influence can be felt. It is the space around magnet. It is the space around magnet in which its influence can be felt. It is the space around the magnet in which its influence can be felt. What is the definition? It is the space around the magnet in which its influence can be felt. Draw this diagram, and it's denoted by B, we all know, and its units are Oersted. Its units are Oersted. After magnetic field, what we have, children? Definition? Line of force. What is line of force definition, children? Line along freely suspended, line along freely suspended north pole. Please keep copying, children. Don't sit idle and see like that. Keep copying. Line along which freely suspended north pole tends means tries, tends to move. Line along which a freely suspended north pole tends to move. Whether they ask or not, compulsory line of force definition is coming. Please draw line of force. North to south, north to south, north to south, north to south. Okay, children, the line along which a freely suspended north pole tends to move. Is a line along which a freely suspended north pole tends to move. Is a line along which a freely suspended north pole tends to move. Next definition. What is the next definition we have in this lesson, children? Swimming rule we have. Swimming rule. What is swimming rule, children? What is the swimming rule? Imagine a person is swimming in the direction of current. Just imagine a person is swimming in the direction of current. Imagine a person is swimming in the direction of current. Then compass needle deflects towards his left hand. Compass needle deflects towards his left hand. Imagine if a person is swimming in the direction of current, then the compass needle deflects towards his left hand. Okay? Imagine a person is swimming in the direction of current. Imagine a person is swimming. Okay, children? Imagine a person is swimming in the direction of current. Okay? Imagine a person is swimming in the direction of current. Then the compass needle kept under him, or okay, it deflects towards his left hand. This is left hand, no? Towards left hand. Compass needle deflects towards left hand. Next, what is the rule we have? Snow rule we have. What does snow rule states that, children? Snow rule states that if current is flowing, from south to north, if current is flowing from south to north, then the compass needle deflects towards west. Then compass needle deflects towards west. Then the compass needle deflects towards west. Compass needle deflects towards west. Okay, children? If current is flowing like this, children, this is south, this is north, this is west, this is east. The compass needle always deflects towards west. Okay, that is called snow rule. Okay, if current is flowing from south to north, then the compass needle deflects towards west. If current is flowing from south to north, the compass needle deflects towards west. Next one. Right hand thumb rule. Right hand thumb rule gives what, children? Direction of magnetic field. Right hand thumb rule gives what, children? Direction of magnetic field. Okay. If current carrying conductor is held in right hand. If current carrying conductor, don't put flaming or anything, children. It's just right hand thumb rule. Okay. Okay. If current carrying conductor is held in right hand. if current carrying conductor is held in right hand. If current carrying conductor is held in right hand, okay, if current carrying and thumb is in the direction of current, if thumb is in the direction of current, if thumb is in the direction of current, if thumb is in the direction of current, then curling of fingers, curling of fingers gives direction of magnetic field. Curling of fingers gives direction of magnetic field. Curling of fingers gives direction of magnetic field. Okay, children. So imagine a person is holding. Imagine a person is holding with his right hand. Okay, thumb in the direction of current. Thumb in the direction of current is holding. Okay, children, is holding like this. Then curling of fingers gives direction of magnetic field. Okay, children, if he is holding like this, children, if thumb in the direction of current, thumb in the direction, then curling of fingers gives direction of magnetic field. Okay, if current is going upward, magnetic field is like this. If current is going downward, magnetic field is like this. If current is going like this, magnetic field is like this. If current is going like this, my curling of fingers like this, magnetic field is like this. So right hand thumb. Next, Maxwell corkscrew rule. Maxwell corkscrew rule. This also gives direction of magnetic field only. The same like right hand thumb rule. This also gives direction of magnetic field. Maxwell corkscrew rule states that, okay, if Maxwell corkscrew rule states that if current carrying conductor, if we see, children, if there is a tip of the screw like this, if we imagine the tip of screw is in the direction of current, if we imagine tip of screw, if we imagine tip of screw is in the direction of magnetic field, if we imagine tip of screw is in the direction of magnetic field, is in the direction of magnetic field. If tip of screw is in the direction of magnetic field, then rotation of the head of the screw, then rotation of head of screw gives direction of magnetic field. Direction of magnetic field. If you imagine tip of the screw is in the direction of current, if you imagine tip of the screw is in the direction of current, then head of the screw gives the direction of magnetic field. If you imagine tip of screw is in the direction of magnetic current, if you imagine tip of the screw is in the direction of, if you imagine tip of screw is in the direction of current, no one is saying what. If you imagine tip of the screw is in the direction of current, then rotation of head of screw gives the direction of magnetic field. Tip of screw in the direction of current, rotation of head gives direction of magnetic field. Tip of screw is in the direction of current, rotation of head gives direction of magnetic field. This is Maxwell corkscrew rule. Whether it is right hand thumb rule or Maxwell corkscrew rule, both will give direction of magnetic field only. Both will give direction of magnetic field. Draw this diagram if they ask this question. Okay, children. Next definition, we will go for solenoid definition, children. I hope you all understood this definitions. Please draw diagrams also, children, where relevant diagrams wherever it is needed. Okay. Next definition. Seventh definition. Solenoid. What is solenoid, children? Anyone? Circular turns of
copper wire bound on
copper wire wrapped
around
closely in the shape of
cylinder.
cylinder. Circular turns of copper wire wrapped closely in the shape of cylinder. Circular turns of copper wire. Okay. Circular turns of copper wire wrapped closely in the shape of cylinder. Okay. Circular turns of copper wire wrapped closely in which if you keep any object and if you pass the current, it behaves as a magnet. It behaves as a magnet. Circular turns of copper wire wrapped closely in the form of cylinder. Solenoid is very important question. 100% guarantee question, children, in board exam. Every year they ask. Circular turns of copper wire wrapped closely in the shape of cylinder. circular turns of copper wire wrapped closely in the shape of cylinder. Next definition, electromagnet. What is electromagnet, children? Substance which behaves as magnet only when current is passed. Only when current is passed. Who will behave as electromagnet? Example, anyone? Who will behave as electromagnet, children?
Soft iron.
Soft iron. If you want permanent magnet, you have to take steam. If you want electromagnet or temporary magnet, electromagnet or temporary magnet, then we have to take soft iron. Okay, next definition. Electric motor. What is electric motor definition, children? Device which converts electrical energy. You switch on electrical energy, it will move into mechanical energy. Substance which converts electrical energy to mechanical energy. Substance which a device which connects electrical energy to mechanical energy. Where does electric motors we use, children? We use electric motors in grinders, fans, anywhere else, children? Disk, floppy disks, okay, and in remote control cars, small remote control cars, electric motors will be there, children. Okay, so many places we use it. Motor. Okay, if we are switching on, if it is rotating, means it is motor. Motor converts electrical energy to mechanical energy. Motor converts electrical energy to mechanical energy. Motor converts electrical energy to mechanical energy. What is principle of motor, children? Principle of motor. Current carrying conductor. A current carrying conductor.
This is magnetic.
When kept in
Magnetic field experiences force.
magnetic field
Experiences
experiences force. Current carrying conductor when kept in magnetic field experiences force. Okay, children, imagine this is a magnetic field. North to south magnetic field will be there, no? Okay, here we are keeping a current carrying conductor. What happens? It experiences force. Current carrying conductor when kept in magnetic field experiences force. Current carrying conductor when kept in magnetic field experiences force. Okay, next. Electromagnetic induction. What is electromagnetic induction? The same is also can be used as principle of generator. Principle of generator. Electromagnetic induction or principle of generator is same. What is the definition, children? Relative motion. Relative motion between coil and magnet. Relative motion between coil and magnet produces. Relative motion between coil and magnet produces current. How? By electromagnetic induction. Okay, children, relative motion means children, relative motion means imagine this is a coil, and this is magnet. Okay, either coil should move or magnet should move. Okay, so relative motion, any one of them, if they are moving in relation to each other, then current is induced, children. If you if you move magnet like this towards it, okay, it will have magnetic flux, children. It will go cut and come out, it will go cut and come out, it will go cut and come out. Due to change in this magnetic flux, current is generated. Okay, relative motion, either this should move or this should move, either this should move or this should move, either this should move or this should. Relative motion between coil and magnet produces current. Relative motion between coil and magnet produces current. Relative motion between coil and magnet produces current by electromagnetic induction. What is definition of generator? What is definition of generator, children? Generator converts, it is a device. Generator is a device, children. It is a device which converts. It's a device which converts electrical energy to mechanical energy. It's a device which converts electrical energy to mechanical energy. Okay.
Here, current is produced.
No, sorry. Mechanical energy to electrical energy. Sorry. Here electrical energy to mechanical energy, and here mechanical energy to electrical energy. It is a device which converts mechanical energy to electrical energy. It is a device which connects mechanical energy to electrical energy. That is the definition of generator, children. Okay, I hope all of you remember generator like this. It will be somewhat, it will be like this. Okay, so when you rotate this armature in magnetic field, when you rotate this armature in magnetic field, current is produced. When you rotate this armature in magnetic field, current is produced. When you rotate this armature in magnetic field, current is produced. So mechanical energy is converted into electrical energy. Mechanical energy is converted into electrical energy. Next definition. Flux. What is flux definition, children? Flux is number of
Lines of force in a
present in
area
given
of magnet.
present in given area present in given area, number of lines of force. Okay, children. So normally magnet will have lines of force, no, children. In a given area, if you take in a given area, suppose this, I will take this much area. In this area, how many lines of force are there? If more lines of force are there, it is strong magnet. If less lines of force are there, it is weak magnet. If I take randomly any area, if less lines of force are there, this is weak zone. If more lines of force are there, this is strong zone. Number of lines of force present in a given area. Number of lines of force present in a given area. Number of lines of force is present in a given area is called as flux. Number of lines of force present in a given area is called flux. Next, what is short circuiting? What is short circuiting, children? Accidental contact of
Live wire and neutral wire.
live and neutral wire. Accidental contact of live and neutral wire. Accidental contact of live and neutral wire. What happens? What happens during short circuiting? Resistance decreases, potential increases, current increases, wire will become very, very hot. It starts melting. On melting, it will break down. On the wire breakdown, current will stop. Okay, resistance decreases, potential increases. Resistance decreases, potential increases. Therefore, so what happens during short circuiting? Better you write, children. Whether they ask or not, what happens during short circuiting? You write down. Next, overloading. What is overloading? Okay, simultaneous usage of many appliances. So many appliances if you use at a time. Simultaneous usage of many appliances. Simultaneous usage of many appliances. Simultaneous usage of many appliances in a given time. Okay, at simultaneous usage of many appliances at the same time. At the same time draws more current. Simultaneous usage of many appliances draws more current. Simultaneous usage of many appliances draws more current. What happens during overloading? Same thing. Current increases, wire will become hot, it will melt, it will break, current stops. Simultaneous usage of many appliances draws more current. Simultaneous usage of many appliances draws more current. Okay? Next. Any more definitions are there, children, for us in this? Okay. Just earth wire don't have any definition, just I'm writing. What is earth wire? Earth wire is wire of green insulation, connected to metallic case of electrical instruments. Metallic cases of electrical instruments. Earthware is wire of green insulation connected to metallic case of electrical instruments. Connected to metallic case of electrical instruments. Okay, children. Okay. So it is normally connected to ground. That's why earthwire is represented like this, children. Earthwire is represented like this, children. Okay, earthwire is represented like this. Earthwire is a wire of green insulation connected to metallic case of electrical instruments. Earthwire is a wire of green insulation connected to metallic case of electrical instruments. Any more definitions we have in this lesson, children? Almost all the definitions we have discussed today. Normally they don't ask. If they ask, what is shunt? If they ask, you write. Okay, a wire of low resistance is called shunt. 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 Okay, children? Just if they ask you, write this definition, children. So, if ever any new definitions are there, I'll add in the description, children. In the description of our video. So before exams or whenever you have time and whenever you're going to magnetism lesson, go through all these definitions. And if you want, you make a note in your textbook so that just go through all the definitions, be perfect with the definitions, and then go through the theory, children. Okay? Anyone have any doubts? Children, you can ask me. So total, how many definitions we discussed here? So 17 definitions I told children. If ever any definitions are coming, I will add in the description of the video, children. All the definitions. So the relevant diagrams also you try to draw, children. Relevant diagrams. Wire of low resistance. Wire of low resistance. Resistance is denoted like this one. Wire of low resistance is called shunt resistance. Okay, children.